Hello students, good evening. In this lecture, I am going to discuss about what is the concept of energy band and the types of energy band like valence band and conduction band. What is the difference between valence band and conduction band? So, based on the energy band, we'll classify insulator, semiconductor, and conductor. Also, based on the resistivity and conductivity, we'll be classifying insulator, semiconductor, and conductor. Then we'll discuss about the types of semiconductor like intrinsic semiconductor and extrinsic semiconductor. Again, extrinsic semiconductor are two type, P type and N type semiconductor. Like we'll be discussing this part in detail. So without wasting time, we'll start the session. So my name is SR Prusty and you are watching my beautiful channel, Love You Science. So let's start. So at first we'll discuss about energy band. You know that energy band two type like conduction band and valence band. You have studied in class 12th. So on the basis of energy band, we can classify insulator, semiconductor, and conductor. The gap between valence band and conduction band is called energy gap. So these are things we have already studied, but we'll understand what is the concept of energy band. Why it has been classified in two categories like valence band and conduction band. एक्चुअल देखो क्या होता है एनर्जी बैंड का डेफिनेशन पहले देखो द रेंज ऑफ एनर्जी पोजेस्ड बाय एन इलेक्ट्रॉन इन ए सॉलिड और क्रिस्टल that is the range of energy or we can say this is bunch of energy level in a solid. You can write this definition, no issue, but let us understand this one. So let us take an example of isolated atom and crystal. Isolated atom, and here I'll take solid or crystal. Isolated atom matlab single atom, and solid matlab there are million of atom that will form a solid or crystal. Right? So isolated atom में क्या होता है? The energy possessed by the electron in a particular orbit is fixed, that is constant. But in case of solid क्या होता है? The energy possessed by the electron in a orbit, there are various electrons, so all will have different amount of energy. So the difference is very small because the interaction of electron of one atom to the electron of other atom in the same orbit. So let us take the example. Let us take the example of silicon, right? Silicon, it is a semiconductor, that you know. सो सिलिकॉन का एटॉमिक नंबर कितना है 14. ठीक है, उसका कॉन्फ़िगरेशन क्या है 2 8 एंड 6. सो आउटर मोस्ट ऑर्बिट में 2 8 एंड 4. सो आउटर मोस्ट ऑर्बिट में कितना इलेक्ट्रॉन 4 इलेक्ट्रॉन. सो लेट अस ड्रॉ द एटॉमिक स्ट्रक्चर ऑफ सिलिकॉन एटम, राइट. सो ये फर्स्ट ऑर्बिट, ये सेकेंड ऑर्बिट, ये थर्ड ऑर्बिट आपका. सो देयर आर 2 इलेक्ट्रॉन इन फर्स्ट ऑर्बिट. सो देयर आर 8 electron in second orbit and 4 electrons in outermost orbit. तो इसमें क्या होता है देखो आइसोलेटेड एटम में एनर्जी इज कांस्टेंट. ये जो 4 इलेक्ट्रॉन है सबका एनर्जी सेम है. सो ऑल द 4 इलेक्ट्रॉन इन दैट outermost orbit will be same. Is it clear? So similarly in the second orbit also, there are 8 number of electrons, so all electrons will have same amount of energy. So that means we'll be getting one energy level in one particular orbit. Is it clear? In case of solid, what happen? As you know, solid is made up of million of like atom, right? So इसमें क्या होता है? There is a interaction between energy of one electron of a atom in a particular orbit to the neighboring atom of same configuration, same orbit, same electron. Let this is a silicon, this is silicon atom. ये हो गया. So outermost orbit में कितना इलेक्ट्रॉन है? There are 4 electrons. Let another silicon atom I have considered here. I have considered another silicon atom. So again there are how many electrons in outermost orbit? 4 electrons, right? So there is a energy interaction. There is a interaction of energy of this electron with this nucleus, or you can say this electron to this electron, or this electron to this electron, or this electron to this nucleus and this electron, right? There is a heavy interaction between that electron of a particular orbit to the neighboring atom of that same orbit. तो इसमें क्या होता है? तो एक एनर्जी डिफरेंस क्रिएट होता है. सॉरी, एक एनर्जी डिफरेंस क्रिएट होता है. So that energy difference is very small. That energy difference is very small. Conclusion क्या मिलेगा? There will be a bunch of energy level. Bunch of energy level will be getting. That bunch of energy level is nothing but energy band. It may be valence band or conduction band. That I'll discuss. Is it clear? So you can say bunch of energy level is nothing but energy band. There are two type of energy band. One is called valence band. Second is called conduction band. One is called valence band. Second is your conduction band. Right? Valence band क्या है? The range of energy possessed by the electron in valence orbit. The range of energy, the range of energy level possessed by the electron in valence orbit or outermost orbit. Conduction band क्या होता है? If we'll give little bit amount of energy to that electron in valence band, then that electron will be getting some energy and it will be excited. It will be free. If it is free, it will have more amount of energy. That bunch of energy line is nothing but conduction band. Bunch of energy line. Which energy line? Conduction. It is called conduction band. Why it is called conduction band? Because valency band में जो electron है, it will give little bit amount of energy. It will be free, so it will have a higher amount of energy. That bunch of energy is nothing but conduction band. Okay, ये हो गया आपका valency band. ये हो गया आपका conduction band. valency band में electrons actually है. Conduction band में हो सकता है, नहीं भी हो सकता है, right? So the gap between these two bands is nothing but energy gap. But actually this is not the definition. The gap between the upper level of valence band, upper energy level of valence band, बार बार बोल रहा हूँ, repeat कर रहा हूँ sentence, upper level of valence band and lower level of conduction band is called energy gap or forbidden energy level, right? So don't say it is a gap between valence band and conduction. There are various energy level. Here also there are various energy level, right? So the upper energy level of valence band and lower energy level of conduction band, this gap is called energy gap. So यहाँ पे electron नहीं होता है, right? If we give energy to the electron in valence orbits, it will jump to conduction band, right? Okay, let us understand what is the real meaning of this graph, valence band and conduction band. यहाँ पे देखो, I'm drawing a graph here. I have taken 1 by r in x-axis and energy in y-axis, right? So I have taken two ranges. One is called isolated range, or atom is in isolated form, isolated atom, and after that I have taken what, like solid or crystal. ये axis आपका 1 by r है. R is nothing but separation between two atoms. Let A and B are two atoms in a crystal. The separation is nothing but r. So now the point is, if 1 by r will increases, that means r is decreasing. If r will decreases, atoms have become more closer to each other. So more will be the interaction. The chances of interaction will be more, right? So if I take silicon atom, see, if I take silicon atom here, सिलिकॉन एटम में आउटर मोस्ट ऑर्बिट में इलेक्ट्रॉन कितना है, 4 है. तो एनर्जी लेवल ये 3s2 है एंड 3p2, राइट? 3s2 मतलब क्या है, ये दो इलेक्ट्रॉन है आउटर मोस्ट ऑर्बिट में इन s सबसेट, राइट? एंड सिमिलरली 3p2 क्या है, so there are again two electron in two subcell and one is vacant, right? ये p subcell, ये s subcell, right? But tell me one thing, there are how many state, energy state here? 2n state. Maximum 2 electron can be filled. But here how many state? It will be 6n state. So ये range तक energy same होगा. 3p में जो एनर्जी है, 3p में जो भी इलेक्ट्रॉन है, दोनों का एनर्जी सेम होगा, और 3s में जो भी दो इलेक्ट्रॉन है, दोनों का एनर्जी सेम है. देन जब सॉलिड फॉर्मेशन होगा, धीरे धीरे स्टार्ट हो जाएगा इंटरेक्शन, देन ये एनर्जी क्या हो जाएगा, स्प्लिट हो जाएगा. इसका एक मिनिमम रेंज होगा, एक मैक्सिमम रेंज होगा. सिमिलरली ये 3s2 का भी एक मिनिमम रेंज, एक मैक्सिमम रेंज होगा. देन उसके बाद क्या हो जाएगा, ये तो स्प्लिट हो गया, देन मिक्सअप हो जाएगा। मिक्स होने के बाद all the electrons will try to come to this subcell, okay, because lower energy level है। सो इसमें देर आर स्टेट भी चेंज हो जाएगा। इसमें 4n स्टेट है, 4 इलेक्ट्रॉन, इसमें 4n स्टेट है, 4 इलेक्ट्रॉन, इसमें 4n स्टेट है, 0 इलेक्ट्रॉन। सो ये जो एनर्जी बैंड होता है दिस इज कॉल्ड वैलेंस बैंड। ये जो एनर्जी बैंड होता है दिस इज कॉल्ड कंडक्शन बैंड। एक्चुअल इट इज द रियल मीनिंग, अंडरस्टूड। ये आपका कंडक्शन बैंड है, ये आपका वैलेंस बैंड है। सो एनी हाउ, बट फॉर योर सेमिस्टर पॉइंट ऑफ व्यू यू कैन ड्रॉ दिस डायग्राम। ये आपका एनर्जी एक्सिस है, ये हो गया वैलेंस बैंड, ये आपका कंडक्शन बैंड, ये जो गैप होगा दैट इज कॉल्ड एनर्जी गैप, ठीक है। ये आपका वैलेंस बैंड, ये आपका कंडक्शन बैंड। So now we'll discuss on the basis of valence band and conduction band we can classify conductor, semiconductor and insulator। अगर कंडक्टर बारे में बात करेंगे, कंडक्टर द एनर्जी गैप इज नियरली इक्वल टू 0, ये ओवरलैप हो जाएगा, ठीक है। ये आपका वैलेंस बैंड है, ये आपका कंडक्शन बैंड, ये ओवरलैप हो रहा है, द एनर्जी गैप इज नियरली इक्वल टू 0, आपका वैलेंस बैंड, ये कंडक्शन बैंड, ठीक है। So the gap is the energy gap is nearly 0. मतलब if little bit amount of energy is given to the electron in valence band, it suddenly goes to conduction band. ये हो गया कंडक्टर। देन सेमीकंडक्टर में क्या है, सेमीकंडक्टर में क्या है, द गैप बिटवीन वैलेंस बैंड एंड कंडक्शन बैंड is less than 3 electron volt, less than 3 electron volt। ये आपका कंडक्शन बैंड, ये वैलेंस बैंड। सो कंडक्टर सेमीकंडक्टर क्या, इफ इट इज मेड अप ऑफ सिलिकॉन द एनर्जी गैप इज 1.1 इलेक्ट्रॉन वोल्ट, इफ इट इज जर्मेनियम इट विल बी 0.7 electron volt। is it clear? That means the range lies between 0 to 3 electron volt। So if it is silicon it is 1.1 electron volt, if it is germanium 0.7 electron volt। what that means 1.1 electron volt मतलब क्या है, 1.1 into 1.6 into 10 to the power minus 19 joule। if that much amount of energy is given to the electron in valence band then it goes to conduction band, ठीक है, it is clear। next is insulator। insulator में energy gap will be more than 3 electron volt। ये आपका ये हो गया कंडक्शन बैंड, ये वैलेंस बैंड। ये जो आपका गैप होगा, आई एम टॉकिंग अबाउट इंसुलेटर। इंसुलेटर द गैप इज एनर्जी गैप इज मोर देन 3 इलेक्ट्रॉन वोल्ट। द एनर्जी गैप इज मोर देन 3 इलेक्ट्रॉन वोल्ट, ओके, इट इज क्लियर। So on the basis of conductivity, resistivity, resistance, conductance, also we can classify conductor, insulator and semiconductor। ये कंडक्टर, ये हो गया सेमीकंडक्टर, ये इंसुलेटर, राइट। ऑन द बेसिस ऑफ रेजिस्टिविटी, on the basis of resistivity rho, the resistivity is very less in case of conductor and it is extremely high in case of insulator and it is moderate in case of semiconductor। Here if resistivity is less then you can say conductivity will be more because conductivity is inverse of resistivity, so conductivity will be more in case of conductor। in case of insulator it is very less, right, it is very less, 0, right, current cannot flow, here current can easily flow and here the conductivity is moderate, मतलब little bit amount of current can flow in terms of milliampere or microampere, right, is it clear? That based on the conductivity and resistivity also we can distinguish between conductor, semiconductor and insulator, okay। Now we'll discuss about what is the properties प्रॉपर्टीज ऑफ सेमीकंडक्टर। सेमीकंडक्टर का क्या क्या प्रॉपर्टी होता है? What are the properties of semiconductor? The first property, you remember, semiconductor is formed in form of crystalline form. Crystalline form, right? And second point is इसमें covalent bond होता है, covalent bond, not ionic bond, right? And third point is the resistivity. The resistivity like rho is moderate, as I've told. Moderate. मतलब resistivity of conductor is very less and insulator is very high. Resistivity of semiconductor is moderate in between conductor and insulator. And fourth point is very important, negative temperature coefficient. It has negative temperature coefficient, matlab if temperature increases then resistance will decreases. That is called negative temperature coefficient, right? And fifth point is important, ये सेमीकंडक्टर में क्या होता है, दी वैलेंस बैंड इज कंप्लीटली फील्ड, इट इज कंप्लीटली फील्ड होता है, बट कंडक्शन बैंड नियरली एम्प्टी होता है। कंडक्शन बैंड जो है, कंडक्शन बैंड नियरली एम्प्टी होता है, राइट? ओके, दीज आर द बेसिक प्रॉपर्टीज ऑफ सेमीकंडक्टर. So now we'll discuss the classification of semiconductor. So we can classify semiconductor in two categories. One is called intrinsic semiconductor, second is extrinsic semiconductor. Intrinsic semiconductor क्या होता है? It is pure semiconductor. Like it has only four electron in outermost orbit. You can say it is made up of tetravalent atom only. Example क्या है? Silicon or germanium, that comes under group 14 elements, right? But extrinsic semiconductor क्या होता है? It is impure semiconductor. Like impurities is added to that intrinsic semiconductor, which will form extrinsic semiconductor. It is again classified in two categories, like p type semiconductor, n type semiconductor. p type semiconductor क्या होता है? Like if group 13 element is added to group 14 element, if trivalent atom is added to tetravalent atom, that will form p type of semiconductor, right? और n type semiconductor क्या होता है? If pentavalent atom is added to tetravalent atom, that is n type semiconductor. The process at which the impurities is added is called doping, and the impurities is called dopant technically, right? So what I've told, semiconductor are two types. I'll explain briefly this one. One is called intrinsic semiconductor, second is extrinsic semiconductor. ठीक है? Intrinsic semiconductor is pure semiconductor. Okay, first point. So it is made up of tetravalent atom. Tetravalent atom मतलब which has 4 electron in outermost orbit और group 14 elements. Example क्या है? Silicon or germanium. It is pure. There is no impurities. But extrinsic are two types. One is n type and second is p type, right? So one is n type, second is p type. N type में क्या होता है? Tetravalent atom is primary atom plus pentavalent atom is added as impurities. So this pentavalent atom is called impurities, or you can say it is dopant. क्या बोलते हैं इसको? Dopant. And the process is nothing but doping. The process at which impurities is added to the tetravalent atom is called doping. Is it clear? Example क्या है? देखो, you can say germanium as tetravalent atom and your arsenic as pentavalent atom. So arsenic plus germanium, that will form n type of semiconductor. Mostly that kind of semiconductor we are using, right? So p type semiconductor क्या है? Your primary atom is tetravalent and impurities is trivalent atom. So you can say if trivalent atom is added to tetravalent atom, it will form p type of semiconductor. नहीं, right? इसमें क्या है? ग्रुप 14, ये ग्रुप 14 है, ये ग्रुप क्या है? 15. तो इसमें क्या है? ये ग्रुप 14, ये ग्रुप क्या है? 13. मतलब trivalent atom, if it is added to tetravalent atom, it will form p type of semiconductor. Like your germanium is primary atom, you can say gallium as trivalent atom. So it will form a pentavalent p type of semiconductor. Is it clear? Okay. So let us understand briefly what is intrinsic semiconductor with its diagram. Now we'll talk about the detailed construction of intrinsic semiconductor with its working principle. So as I have told, intrinsic semiconductor is pure semiconductor. There is no impurities and it is made up of tetravalent atoms like 4 electron in outermost orbit. Example is like germanium or silicon. Right. So let us consider a silicon crystal. Let me draw first. Okay, there are 9 atoms, but actually in silicon, million of atom is there uh, to make a crystal. These are the covalent bonds. Okay, ये सब covalent bond है. ठीक है. As I have told in properties of semiconductor, so it forms covalent bond. ठीक है. ये हो गया the structure of silicon crystal. Now what will happen? In intrinsic semiconductor, usually conductivity is very less. First thing you remember, conductivity is very less. Why? I'll tell you. Actually, at low temperature, if temperature is very less, then that bond cannot break. But in case of room temperature, if I increase the temperature, the bond will break. The covalent bond will break. If covalent bond will break due to increase in temperature, what will form? The electrons will be free. The electron will be escape out from that orbit. Then what will happen? The electron and hole pair will generate. Electron and hole pair generates. How? Since electron is escape out, one vacant space is left, that is called hole. Right? So you can write in case of intrinsic semiconductor, it is made up of pure semiconductor. At room temperature, nothing will happen. Sorry, at low temperature, nothing will happen. At room temperature, the bond will break and electron hole pair will generate. Right? Then after what happens? If we give some potential difference, or if we give some voltage to that semiconductor, let it is germanium, right? These are the holes and electrons, right? It is a intrinsic semiconductor. If I give some potential difference, then what will happen? The negative terminal of the supply will repel the electron, and positive supply will what? Repel the hole. So hole ka movement kya hoga? The hole will flow towards the negative terminal, electron will move towards the positive terminal. Then you can find out a current. This current is nothing but conduction current. You can say it is due to hole current and electron current. Is it clear? This conduction in case of intrinsic semiconductor is due to first point generation of electron and hole pair. Then after applying some EMF or potential difference to that semiconductor, then the flow of electrons or hole will take place. And the electron will move towards the positive terminal of the battery and hole moves towards the negative terminal of the battery. As you have considered hole as a positive charge, but actually hole is a vacant space which can be filled by other electrons. Is it clear? That is all about intrinsic semiconductor. But इसका disadvantage क्या है? If we again decrease the temperature, if temperature will again decrease to low, then it will come back to its original position, right? Then nothing will happen. What is the drawbacks of intrinsic semiconductor? Or what is the disadvantage? Disadvantage मतलब at low temperature or 0 Kelvin, you can say it will act as insulator because electron hole pair will not generate, right? Next is extrinsic semiconductor. Extrinsic semiconductor, as I have told, it is impure semiconductor, and there are two types. One is N type and second is P type, right? So P type में मैंने क्या बोला था? The tetravalent atom plus trivalent atom. इसमें क्या है? Tetravalent atom plus pentavalent atom. Like 5 electron will be there in outermost orbit, 4 electron will be there in outermost orbit. ये primary atom है, ये dopant है, right? यहाँ पे भी same thing, primary atom and dopant. ठीक है, we'll draw the constructional diagram of N type semiconductor. देखो N type semiconductor क्या है? Okay, let have taken germanium, right? How many electrons in germanium? There are 4 electrons in outermost orbit. If I added arsenic as impurities, how many electrons in outermost orbit of arsenic? There are 5 electrons. ठीक है, so ये हो गया आपका जर्मानियम. Just wait, I'll draw the diagram. Okay, so it will form a these are the covalent bond. ये covalent bond है, ठीक है. These are the covalent bond. Okay, ये हो गया constructional diagram of N-type semiconductor. What will happen here? See, due to this pentavalent atom like arsenic, we have some additional electron, right? So due to increase of temperature, bond will break. Then we can apply some potential difference, then conduction takes place. But here, one thing you will notice, some additional electron is there. That means we can say the majority charge carrier is electrons and minority charge carrier is hole. Because if bond will break, then electron hole pair will generate. The number of electron will be number of holes that will be generated. But due to the impurities, some additional electron will be there. So matlab we'll find out majority charge carrier as electron, minority charge carrier as hole. Is it clear? So that means in case of N-type semiconductor, what you conclude, the first point is pentavalent atom is doped with tetravalent atom. It is point number 1, right? Example like arsenic plus germanium. Is it clear? Next is conductivity takes place due to majority charge carrier. Conductivity takes place due to majority charge carrier. So here majority charge carrier क्या है? Majority charge carrier is electron, minority charge carrier is hole. Is it clear? So question आ सकता है, what is the difference between P type and N type semiconductor? In case of N-type semiconductor, you can note down this 5 points: majority charge carrier electron, minority charge carrier hole, conductivity takes place due to majority charge carrier. Example is like arsenic plus germanium. And here pentavalent atom is added to tetravalent atom. Pentavalent atom is called dopant. The process is called doping. Like your N-type semiconductor में majority charge carrier क्या है? Electrons. These are the majority charge carrier. And these are the minority charge carrier. Holes are the minority charge. This is hole and this one is electron. Then if we give some potential difference of V, then the flow of electron will be towards the positive terminal of the battery and the flow of hole towards the negative terminal of the battery. But here the major responsible charge carrier is electrons, right? So now we'll discuss about P-type semiconductor. P-type semiconductor क्या है? मैंने क्या बोला था? Trivalent atom is added to tetravalent atom. So here dopant is trivalent atom. like your example क्या है, gallium tetravalent क्या है, germanium, you can take gallium plus germanium, so this will form a p type semiconductor. So definition क्या है, if trivalent atom is added to tetravalent atom, then p type semiconductor will form, right? So here the diagram will be, this is your germanium and this one is gallium. In gallium we will find 3 electrons, right? So this is your germanium again. ठीक है, so these are the covalent bond, you can say. Okay, let this is germanium. Then here what will happen, one vacant space will be there which can be filled by the electron, right? This vacant space is called hole. So that means the majority charge carrier is here hole and minority charge carrier is electrons. So here the major responsible of conduction due to the majority charge carrier as hole. Okay, so the diagram will be like this. The majority will be holes, right? Minority will be electrons. Will give potential difference, then hole will move towards the negative terminal, electron will move towards the positive terminal, then conduction takes place. Okay, clear? So overall I'll write some point, you can note down. अगर p type n type का classification करना है, p type में first you can write down the trivalent atom is doped with tetravalent atom. Your impurities is trivalent. Here pentavalent atom is doped with tetravalent atom. And second point you can write down the example like gallium plus germanium. Here arsenic plus germanium. Now next point is majority charge carrier is here holes. Minority charge carrier is electrons. Here majority charge carrier is electrons. Minority charge carrier is holes. Is it clear? Next, major responsible for conduction is here majority charge carrier as hole, and here major responsible conduction for conduction is your majority charge carrier, that is your electron. So these are the points you can write down. So with this I am ending this lecture. So if you like my video, so please do subscribe and comment box में comment भी लिखना है, so that I need to improvise. So thank you so much.